As I mentioned in the last example, we're in 4.4 day 1, and we're talking about amplitude, period, and not really frequency. But in this case, I just want to focus on amplitude for this example. Amplitude has to do with vertical stretch or shrink. Now, I told you in the last example that the basic amplitude is 1, so that's half of the distance. If I think about the center of this graph, a dotted line just going through the center of each of these graphs, then the amplitude is going to be how far away can I get from that. So if I'm right here, I'm 1 away from the center of that graph, from that center axis. So what we're going to do now is we're going to modify these amplitudes a little bit, and it happens to be with vertical stretch and shrink. So we're going to comment on, once we have this change, we're going to say what transformations happen, and you can already count on vertical stretch and shrink. Now, when we have that 3 out in front, that 3 is going to indicate what our amplitude is. So when you see the 3 there, we're just going to put that our amplitude is equal to 3. Now, one thing about amplitude I haven't mentioned to you before is that amplitude is always positive. Our amplitude is always going to be positive. So the amplitude here is 3. Now, if I've got a -4 here, the negative will do something to the graph, but it's not going to change the amplitude. The amplitude is still going to be a positive number, and in this case, it is 4. So now let's say I wanted to change what this graph looked like based on these different amplitudes. Now, this one's just a +3, and so what that'll do is I'll just take this point right here and I'm going to multiply it by 3. That's what a vertical stretch is anyway, and that puts this point up here to +3. Now, if I multiply 0 by 0, it just stays as 0. So everything that's a 0 on the graph will stay as a 0 on the graph. But if I take now this minimum, this is -1, I multiply that by 3, I get that point way down here. And so now if I sketch this graph, it's still a sine graph, but it is stretched out vertically on that one. All right, so that's with the first one. Now the second one, we have, instead of just cosine, we have -4 cosine, and it's going to do a lot of the same thing, except for, notice that there is that negative out in front. So I'm still just going to use it like I would any vertical stretch or shrink, but in this case the negative also makes it flip. So I'm going to take this one, this has a y value of 1, I multiply that by -4, and then it flips it to -4. If I have a y value of -1 right here, and I multiply it by -4, that flips it to +4. And then again, +1 multiplied by -4 gets you to -4. So when I draw this one in, it's going to be reflected and it's going to be stretched vertically. So the transformations that happen on these, when we have an amplitude of 3, that means that we are going to do a vertical stretch by a factor of 3. When we have an amplitude of 4, it's a vertical stretch by a factor of 4, but that negative also means that we are going to reflect over the x-axis. Almost all of your reflections in this chapter will be over the x-axis. There will be maybe a couple that are y-axis, but you can expect to see that. Now, if we had fractions in front of there instead of whole numbers, then of course we would have a vertical shrink instead of a vertical stretch.